Now going to put everything that we've learned about exponential and logarithmic equations together, and we're going to solve some of these logarithmic and exponential equations. So let's start off with number 1. Log base 3 of x equals 5 means that x equals 5 to the third. So x is 125. If log base y of 8 is equal to 4, then y to the fourth is equal to 8, and y is equal to plus or minus, not plus or minus because y has to be positive, the fourth root of 8. So that is a good enough answer right there. This is 2 to the 3/4 if you would like. Log base 6 of x minus 2 is equal to 1. Then x minus 2 is equal to 6 to the first, which is 6. X minus 2 equals 6. And x is equal to 8. Moving on, if log base 10 of x plus 5 equals log base 10 of 4x plus 2. Let me check my domain before I keep going here. This would be that x plus 5 needs to be greater than 0, so x needs to be greater than -5. This is 4x plus 2 needs to be greater than 0, so 4x needs to be greater than -2, and x needs to be greater than -1/2. So -1/2 is bigger than -5, so we're going to stick with this for the domain. I can use my one-to-one property and drop the logs because they have the same base. And I can solve and say that that means that 3x is equal to 3 and x is equal to 1. And this 1 is certainly bigger than that -1/2. So that's a good answer. Let's go back and check it and make sure log of 6 is equal to log of 6. Yep. Want to check for extraneous solutions when we have logs to make sure that we don't accidentally get 0 or a negative number inside. So log base 10 of 5 plus x minus log base 10 of x minus 5 equals log base 10 of 3. There we go. So I'm going to rewrite this as division. Plus x minus 5. And same thing here, the x needs to be greater than -5, and x needs to be greater than 5 here. 5 wins. So 5 plus x over x minus 5 equals 3. 5 plus x equals 3x minus 15. Subtract x from both sides. 5 equals 2x minus 15. Add 15. 20 equals 2x. And x equals 10. It's greater than 5, so we're in good shape. I'm going to come back and check it. 15 minus 5, when I divide them, is going to be 3, which is what it says on the right-hand side. Log of 3x equals log of 4 plus log of x minus 1. Let's bring this log from the right over here to the left and make this log of 3x over x minus 1 is equal to log of 4. Since x is greater than 0, this is x greater than 1. greater than 1 is my domain for the whole thing. 3x over x minus 1 needs to be equal to 4. 3x equals 4x minus 4. X, negative x equals a negative 4. X equals to 4. 4 is greater than 1. 12. And 4 times 3 is 12. We're in good shape. Log base 8 of 5x plus 2 equals log base 8 of 5x plus 5. So if I drop the logs here in just a second, 5x plus 2 greater than 0, x greater than a negative 2/5, x greater than a negative 1 here. Negative 2/5 is bigger than a negative 1. So I'm going to go with that. If I drop the log base 8s with the 1-to-1 property, 5x plus 2 equals 5x plus 5. And I have a problem because when I subtract the 5x's from both sides, 2 equals 5. There's no solution here. It's never going to work. Log base 3 of x plus log base 3 of x minus 24 is equal to 4. Log base 3 of x squared minus 24x is equal to 4. X squared minus 24x is equal to 3 to the 4th is 81. X greater than 0, x greater than 24. That's my domain. Squared minus 24x minus 81 equals 0. (27) and 3. Minus 27 equals 0, or x plus 3 equals 0. X equals 27, or x equals negative 3. Negative 3 is not greater than 24, but 27 is. So that should be my only answer. Log base 3 of 27 is 3. 27 minus 24 is 3. Log base 3 of 3 is 1. 3 plus 1 is 4. If I had tried to stick the 3 in, I would have gotten a negative 21 inside of the second log, and that doesn't exist because the argument of the log has to be positive. 1/3 log base 2 of x plus 6 equals log base 8 of 3x. Notice that the bases are different here. So I'm going to have to change everything into the same base. Let's change base 8 into base 2. That's pretty easy to do. 1/3 log base 2 of x plus 6 equals log base 2 of 3x over log base 2 of 8, like that. And so this is going to be x greater than negative 6, x greater than 0, x greater than 0 is my domain. 1/3 log base 2 x plus 6 equals 1/3, because this is 3, log base 2 of 3x. Multiply both sides by 3. Get rid of the log base 2's. X plus 6 equals 3x. Subtract x from both sides. 6 equals 2x. X equals 3. 3 is greater than 0. 1/3 of log base 2 of 9. Is that equal to log base 8 of 9. This is log base 2 of 3 to the 2/3. And this is log base 2 of 9 over, let's leave the 1/3 there. Over log base 2 of 8. It's 1/3 log base 2 of 9 equal to 1/3 log base 2 of 9. It certainly is. So there we go. That's our solution, x equals to 3. We're on number 10 now. Log base 2 of 3x minus 2 minus log base 2 of x minus 5 is equal to 4. X greater than 2/3, x greater than 5. 5 is bigger, so there's my domain. Log base 2 of 3x minus 2 over x minus 5 equals 4. 3x minus 2 over x minus 5. 2 to the 4th is 16. 3x minus 2 equals 16x minus 90. Subtract 3x, add 90. 88 is equal to 15x. X is equal to 88 divided by 15. And I don't see any common factors, so I believe I'm done. Log base 3 of, I need to go back and make sure that that's within my domain. 88 over 15, that is 6 and 8/15. Yes, that's bigger than 5. Right. Log base 3 of x minus 5 plus log base 3 of x minus 11 is equal to 3. X greater than 5, x greater than 11, x greater than 11 wins. So that's my domain. Log base 3 of x minus 5 over x minus 11 equals 3. X minus 5 over x minus 11 equals 3 to the 3rd is 27. X minus 5 equals 27x minus 270 plus 27 is 297. Subtract x plus 297. 26x equals 292. X equals 292 divided by 26. It's a number that's a little bit, I don't think that's big enough. Let's check it out. $292 divided by 26. Oh, just big enough. Okay, so it's just a little bigger than 11, and that's what I needed to be in my domain. All right, that was 11. Let's check 12 and 13 here. Log base 4 of x plus 4 equals 2 plus log base 4 of x minus 4, x greater than negative 4, x greater than 4, x greater than 4 is my domain. Log base 4 of x plus 4 divided by x minus 4 equals 2. X plus 4 over x minus 4 equals 4 to the second is 16. X plus 4 equals 16x minus 64. Subtract x, add 64. 68 equals 15x. X equals 68 over 15. So 15 times 4 is 60. So 68 is bigger. 68 over 15 is bigger than 4. I'm in good shape. Log base 15 of x plus 30 equals 3 minus log base 15 of x. X greater than negative 30. X greater than 0. X greater than 0 wins. That was odd. There we go. So log base 15 of x squared plus 30x equals 3. X squared plus 30x equals 15 to the third. So that's 225 times another 15 is 2. Let's see, this is 25, 10, 12, and 11, 225, 7, 3, 3. X squared plus 30x minus 3375 equals 0. Let's see. Factors of 3375, 1 and 3375. 6 and 12 is 18, so this is 3 and 11, 25. 5 and 6, 75. Let's see. 15 and 2, 25. 75 and 45. There we go. That's what I want. They have a difference of 30. So x plus 75, x minus 45 equals 0. X equals a negative 75 or x equals 45. I need an answer that's bigger than 0, not an answer less than 0. So x equals to 45. And then one more here. 2 plus log base 3 2x plus 5 minus log base 3 of x equals 4. So I'm going to subtract 2 from both sides. Log base 3 2x plus 5 over x equals 4 minus 2 is 2. 2x plus 5 over x equals 3 squared is 9. X greater than negative 5 halves, x greater than 0, x greater than 0 wins. 2x plus 5 equals 9x. Subtract 2x from both sides. 7x equals 5. X equals 5 sevenths. And 5 sevenths is greater than 0. So we're in good shape. Come back and we will solve the exponential equations in our next video.